Section 1.2, functions. Once again, starting with some important terms. A function is a relation in which every element of the domain goes to exactly one element of the range. A lot of students get this definition mixed up with the definition of a one-to-one function, which we are not going to talk about now, but we will later on. A function only is true in one direction. Every element of the domain, so look at every single domain value, it can only have one value of the range that it is matched up with. Function notation, really all function notation does is it guarantees that the relation is a function, and f of x replaces your variable y. So if you don't like function notation, you're not comfortable with it, just remember that f of x is just taking the place of the variable y, and the only thing that that tells us when it's written in terms of f of x is we know the relation we're dealing with is indeed a function. Domain is the set of all x values or inputs into an equation. To identify the domain when we are looking at the graph of a relation, the domain, you will ask yourself the question when you are looking at the graph, how far left does this graph go? How far right does this graph go? And that's how you can identify pretty easily the domain from the graph of a function. The range is the set of all y values or the outputs. Likewise, when you are looking at the graph of a relation and you are asked to identify the range, you would be asking yourself, how far down does this graph go? How far up does this graph go? That is how you can identify both domain and range pretty easily from the graph of a relation. Okay, let's start with our ordered pair relation here, where S is equal to the three ordered pairs, 1, 3, negative 5, 4, and 7, 3. First question, what is the domain? Well, the domain, remember, is our x values or inputs. We put in 1, we put in negative 5, and we put in 7. There's our domain. Really, notation-wise, you should be writing these in order, so let me do that here. Negative 5, 1, and 7. What is the range? 3 and 4. Question is S a function? Yes, it is a function. The reason it is a function is every element of the domain is paired with one element of the range. Some students look at this and say, oh, it's not a function because 1 is going to 3 and 7 is going to 3. Remember though, your definition of just a function says that every element of the domain goes to exactly one element of the range. 1 in this case only goes to 3. Negative 5 only goes to 4. 7 only goes to 3. So when we're talking about a function, it doesn't have to be true in reverse. It only has to be true from domain into range that each element is matched up with only one element of the range. Which equations represent y as a function of x? So looking at this first equation here, 2x squared plus y plus 1 equals 0. We need to decide, is this a function? In order to do that, solve for y. So I'm going to subtract the 2x squared over. I'm going to subtract the 1 over. We're asking ourselves the question, is this function, or is this equation a function? In this case, yes, it is a function. Reason being is there can never be a single value that I put in here for x where I'm going to get two different y values out. Therefore, this is a function. Letter B. Solve this again for y. We get y squared equals negative x plus 6. Finish solving for y. We have to take the square root of both sides. Remember, when we take a square root within an equation, we have to consider the positive and negative values. So now you're asking yourself the question, does this equation represent a function? No. The reason that this is not a function is every single value that I plug in here for x, I'm going to get out two different values for y because of this plus or minus out front. Therefore, this is not a function. Given the function f of x equals x squared minus 4x, find f of 3. Well, f of 3 simply means in our function, every place I had x, I'm going to put in 3. So I have 3 squared minus 4 times 3. 9 minus 12 is negative 3. Now, don't forget, when you are given a situation like this, where you are evaluating a function at a specific value, you are basically finding an ordered pair here. So this means when I plug in 3 for x, what did I get out for y? Because remember, f of x replaces y. We got out negative 3. So now I know that ordered pair is a solution to that equation. F of a. To find f of a, simply take and plug a in every place you have x, and you're going to get a squared minus 4a. No simplifying we can do here. That is it. Letter C, f of x plus h. Now every place I have x, I'm going to put in x plus h. There is some simplifying here we can do now. We can FOIL out this first binomial. X plus h squared is x plus h times x plus h. Gives us x squared plus 2xh plus h squared minus 4x minus 4h. There are no like terms here, so there is nothing else we can simplify. Last one. Evaluate each expression for f of x equals x plus 1 when x is greater than or equal to 0, and it equals negative x when x is less than 0. So let's evaluate each of these first, then we will look at the graph of this function. F of 2. Okay, the key here to this problem, first of all, when we have a function like this, that in this case has two different equations we're looking at, that is called a piecewise function because it comes in pieces. Its function is going to look like the line y equals x plus 1 for x values greater than or equal to 0. This function is going to look like the line y equals negative x for x values less than 0. So when I evaluate f of 2, we need to pay attention to which piece we are going to plug 2 in. Well, f of 2 is going to look like this piece up here because that is greater than or equal to 0. Plug 2 in, we get 2 plus 1, which is 3. So that means I would have the ordered pair 2, 3. Second piece. Negative 5, I'm going to plug into the bottom piece this time because negative 5 is less than 0. So we have the opposite of negative 5, which is 5, which means we're going to have an ordered pair at negative 5, 5. So let's go ahead and graph this piecewise function. For f of x equals x plus 1 for x is greater than or equal to 0. So let's plug in 0. When I put 0 in here, I get 0 plus 1, which is 1. I'm only going to the right. Values greater than or equal to 0. So put in 1, we get out 2. Or now you could just use the slope, which is 1, up 1, over 1. And we're going to connect that with a straight line. Notice I did not go past that value of 0 here on the left because now for x values less than 0, it's going to look like the equation negative x. So let's plug in 0. If I put 0 in, I'm going to get out 0. But that's not included for this piece, so I'm going to draw that as an open dot. And now my slope is negative x. So rise over run, up 1, to the left 1, up 1 to the left 1, and so on. And there's our second piece of the function.